Welcome. Welcome everyone. I'll give you a couple of minutes to find your way in and just get relaxed and ready for our awesome program. Welcome to the College Admissions Collaborative, highlighting engineering and technology virtual college fair. We have an awesome program for you this afternoon. I have just a couple of housekeeping items before I turn it over to our panelists. First of all, this is a webinar, so you're muted and your video is off, so our panelists cannot see or hear you this afternoon. There are more sessions, and so if you want to hear about particular institutions, there's 2 more hours, 3 more hours worth of you being able to sign up for school-specific information, and you can find those at strivescan.com/CACHET. And lastly, we know you're going to have some questions, and so we hope that you'll use the Q&A at the bottom of your screen to type in your question. If your question is directed at a particular institution, make sure you do list the institution that you're directing your question to so they can answer appropriately. So without further ado, I'm going to turn it over. Good luck and have fun.
Great. Thank you so much, Courtney. Appreciate it. Good evening, everyone. Thank you for joining us for our session, Pathways into Robotics, Autonomous Systems, and Artificial Intelligence with Kettering University and Illinois Institute of Technology. My name is Bree Baker. I'm an admissions counselor at Kettering, and I will be moderating today's session. Again, before we get started, I wanted to remind everybody to please submit any questions that you have for our panelists using the Q&A or chat feature at the bottom of your screen. We'll be addressing those as they come in, and we will get through as many questions as we can. And just note, again, this will be recorded. If you need to go back and review it at a later date, you absolutely can do that. So at this time, I'm going to have our panelists introduce themselves, share their name, title, institution, and programs, and just some background that they have about themselves and their institutions. So Dr. Spenco, if you would like to start us off.
Sure. Hi, everybody. I'm Matt Spenco. I'm a professor of mechanical and aerospace engineering at Illinois Tech. I have been here for about 14 years now, and I specialize in mobile robotics, and our most recent projects revolve around soft robots and how to control them, how to design them, and also navigation safety. So trying to think about how robots localize themselves in the presence of undetected sensor faults. So you can imagine this might become very important if we were to ever get 20 million self-driving cars on the road at the same time. Even small numbers of errors that happen in those sensors can have drastic effects. So we try to quantify those effects and make sure everything is safe.
Thank you so much. Dr. Farmer, if you'd like to introduce yourself.
Sure, thank you. Hi, everybody. I'm Mike Farmer. I'm the department head of Kettering University. And I've been have an interesting background. I did 20 years in industry, so 10 years in aerospace, which is like defense works, surveillance radars and things like that, and 10 years in automotive. And back in the 90s, I was actually building automotive radars. So I'm really enjoying seeing the forefront of autonomous vehicle technology coming forward, and everything from simple autonomous cruise control to fully autonomous vehicles is just radar is such a key part of that. I've been in academia for the last 16 years. Actually, I decided to take some of my knowledge from industry and try and help apply it to more even further forward-reaching ideas, and also to help young students and things like that learn things like AI, take those kind of technologies and advance them. So I'm really excited to be here. Love to hear some questions and see if we can help you guys decide on a career in robotics and artificial intelligence. It's the way to go. It's the future. The growth industries, the 3 top career growths right now are artificial intelligence, data sciences, which you may have heard of, and robotics. So this is just such a great topic to be talking about. And if any of you are really interested in majoring in it, I'm actually kind of jealous because your career is going to be extraordinary. There's so many opportunities for you guys right now. So thanks.
Awesome, thank you. And we already have one question out the gate. What degrees in college will help me in pursuing robotics? Do you take robotics as a major in college, or do you have to take more of a foundational major first, for example, electrical engineering?
I can take that one. That's a great question. I get that often. I wish you could take a undergraduate degree in robotics, but sadly, that's not the case. There may be a couple universities that have something like that. I haven't really there's nothing comes to note of that. Typically, you do need to take something a little bit more foundational. I would suggest the top two would be mechanical engineering or computer science. I think electrical engineering, historically, there's been a lot of robotics coming out of that. I don't see as much recently, but that could be anecdotal. I would say most roboticists come out of computer science, and then a decent portion come out of mechanical engineering. Let me add one more thing to that. Typically, you would get an advanced degree in robotics. So at a minimum, a master's degree, where you will see specializations in robotics, or a PhD degree.
Right, and I could just add briefly to Dr. Spenco, another field that's sort of a crossover field is the computer engineering field. So at Kettering, you can get into robotics either through computer science or through computer engineering, and they actually have the core robotics classes, computer science classes more tied to the artificial intelligence side, but that does vary a lot from school to school. So I really encourage you, depending on wherever you're going, don't be shy, reach out to an advisor. Sometimes it's not so obvious which major you might want to select, but certainly as Dr. Spenco mentioned, those are kind of the big three: mechanical engineering, computer science is stepping stones into robotics. The mechanical side tends to be more on the control side and more on the mechanical, no pun intended, the mechanical side of things. Computer science tends to be more on sort of like AI for navigational kind of things, how to guide robots and things like that. And computer engineering would be sort of a blend of the two.
Awesome, thank you very much. And kind of going off of that, in what areas do you really see robotics being applied currently or in the future?
I mean, it's everywhere. It's in a lot of places. It's huge right now. My graduate students, my undergraduates who work in my lab, they're picking up jobs, making more money than I do. So, I mean, it's everywhere. We've got lots of use of drones for a variety of applications. Farming. I just had a student who did an internship with farming robotics. I've got students going off, getting jobs at all the autonomous vehicle manufacturing companies, and that's not even looking at the more traditional robotics stuff, which is probably not as hot, but I mean, just the self-driving cars alone is a huge industry. Warehouse management, any type of, Amazon or Walmart have these massive robotic systems that they're using and actively developing new tools and techniques for. So it's hot right now, and I suspect it probably will be hot for the next 10 years or so.
For sure. As a matter of fact, I was reading an article just the other day for agricultural purposes, the computer vision for weed recognition. The drones, as Dr. Spenco mentioned, fly over fields. And traditionally, farmers would go, no pun intended being a farmer, but I'm not an actual farmer, would go over fields and apply, either broadleaf or grassy herbicides and things in mass doses. And frankly, most of that would end up run off into the water tables and things. And so what they're trying to do is be much smarter in terms of a thing called precision farming. And they actually fly over the fields first with drones and determine areas that need spraying. Some areas don't. Some areas are kind of in depressions and where things tend to flow. And so they don't even bother spraying there because they know the natural runoff will bring the herbicides down there. And so just, strange things like that you don't even think about. Another interesting one I was reading about was robotics for assistance for accessibility. There's all kinds of interesting things, and really smart wheelchairs that help guide people around, to help elevate, to lift them to cabinet levels, to open cabinets. Medical robotics. If any of you have had any relatives had any surgeries lately, it's probably been a robotically operated surgery rather than free-form surgeries. Those are really becoming a thing of the past. So again, there's a phrase we're using in AI, talk about pervasiveness, and we're saying pervasive robotics too, not just pervasive AI, where there's just so many places. Your Roomba driving around your house vacuuming the floor is a great little robot. That 20 years ago would have been unheard of. And so, as Dr. Spenco mentioned, it's sort of like in another 5 years, probably it's going to be where isn't a robot yet, and why isn't it there, rather than where is a robot. So it's really, like you mentioned, extraordinarily exciting time.
Yeah, you bring up really good points, and I'm dating myself a little bit here, but 10 years ago when I was in high school, teachers were always saying, we're preparing you for jobs that we don't even know exist yet. We don't even know what it's going to be. And there's always that cliche, but it's so true. Things are changing so fast that what you're interested now while you're still in high school, that could be totally different by the time you graduate from college. So really interesting insight there. Thank you for sharing. Got a couple more questions rolling in. One student asks, I want to work with my hands more. Should I go into aerospace engineering or a robotics field? Whoever would like to take the lead on that.
Don't go into aerospace. If you like hands-on stuff, I mean, our aerospace program, yeah, we have labs and stuff like that. But if you like hands-on building, then no, most of them don't do any of that at all, because they're dealing with, satellites or large airplanes. So very, very little hands-on work in aerospace engineering. I always said, if any of my students, my young advisees come in and they think, well, I want maybe think I'm going into aerospace or mechanical. I typically say that the people who do aerospace are usually the aerospace geeks. They love it. For whatever reason, they just love airplanes. They love space. It's a very specialized field. And it's great for those people who love it. So if you are part of that and you just love airplanes for whatever reason, definitely go into aerospace. Otherwise, I would recommend doing something a little bit more general, like mechanical, especially if you like hands-on stuff.
Yeah, I couldn't agree more with Dr. Spenco. Aerospace is great, like you mentioned, if you're a real aeronaut. So I have two friends who actually were aerospace engineers. One of them started his own little rocket company, and he calls himself you guys may not know Forrest Gump. He calls himself the Forrest Gump of rockets, because it's always been just this tiny little goofy company that he's played with himself, done little low Earth orbit satellite launches and things. But he just loved rockets, and that's when it went into. The other one is a woman who loved airplanes and went into aerospace and got a job with Boeing, was so excited that she actually got a job working on Air Force One. This was back in the 80s, a new design of Air Force One. And she quit because after 6 years, she was working on the front door design of Air Force One. And that was it for 6 years, the front door design. So you're going to, because as Dr. Spenco mentioned, the things you're working on are so massive, you will be kind of end up pigeonholed in usually something that's not particular. It sounds really cool, that she told all her friends, I'm working Air Force One. I can't say anything because I got a top secret clearance. And, but then when ultimately it was, she was working on the front door, it's like, good grief, for 6 years. So so if you really want to do some more hands-on, more fun, really little gadget kind of stuff, mechanical, electrical, computer engineering, even CS, you'll do more soft robots rather than mechanical robots. That's the place to be. Aerospace and things is really, if you want to build really big stuff and you just always dreamed of being part of going to Mars, then have at it. But it's just a really different kind of field.
Thank you. Sorry, I couldn't find my mouse there for a minute. Thank you. So another question that came in, and we can probably broaden this a little bit more. Is there any way to get an AI internship in high school? Maybe what could I be doing in high school right now to help prepare me for a STEM major in college?
I could start with that to take the strain off of Dr. Spenco and answer all of them. It's not impossible to get an internship in AI in high school. It's not common yet, however. But one of the things to get you there would be really to be great at programming. Because most internships, you're going to be doing more what we call low-level programming. You're going to be helping teams write little pieces of code to do this and that. And another thing you'll often get involved in is testing. That's a great place where people who don't need to know a lot are actually better testers because they accidentally break stuff and they find bugs that a really good developer would have thought, oh, there'll never be a bug there. We're so good at that. And so people who haven't had a lot of background actually make really good testers. The biggest trick would be finding a company. People often think of the big guys. I'll go to Google or Waymo, or I'll go to Amazon or things, but they're actually pretty hard to find positions at. There's a lot of small companies around. For example, in the Michigan area, there's a little company called Perceptron that's been doing computer vision since literally the 70s. And they're always looking for people. There's a company called May that does autonomous driving. There's another thing too you may want to look at, try to look at Automotive Suppliers, because they're the ones doing a lot of the sensors for the self-driving cars. You got the Aptiv, you got the Siemens, you got the Bosch, Continental. All those companies have a pretty active AI group these days. And so that might be an option for you. But again, it's not going to be easy for a high school student, but definitely get in decent amount of programming, Python, C, C++, Java, those sets of languages will really help you.
Awesome, thank you. Next question. I don't know if you had, Dr. Spenco, if you had anything else to add. You're good. All right. Lots of questions rolling in. So if you choose electrical engineering, is there still any possibility working with robotics in the future?
Yes, I didn't mean to say that you can't do that. Electrical engineering is great. Focus on circuits, focus on electromechanical, so motors, basically, sensors, all that kind of stuff. So, the sensors we use, LiDARs, which are emit light that bounce off objects and come back, are huge in robotics. Vision, all that kind of stuff that comes from electrical engineering, definitely.
Another key thing to think about too, that students coming out of high school initially don't necessarily realize is that when you pick a major, you don't have to just stay in that major per se. You can either double major, which is pretty popular. Of course, it adds a little more courses, but it can often be quite popular. Matter of fact, our computer science major at Kettering, we specifically designed it to be double major friendly. So we have almost half of our majors are actually double majors in computer engineering and electrical. Some mechanicals. Mechanical tends to be not very double major friendly because they have so many courses that you have to take to become a mechanical, because it's such a broad field. But electrical is very common to be a double major in like electrical and computer science, or if you don't want to take on that much of a burden, think about minors. Minors are it's like dating in the field, right? So you can do a computer science minor with electrical. And that's MINORS in the type thing too. The auto spell sometimes gets a little goofy, but that's a really great way to customize any of your degrees. So if you're like, I really love electrical, I love circuits, I love building up boards and making things run and stuff like that, that's cool. And then add a little bit of the software side of life and get a computer science minor or a computer engineering minor would be pretty EE friendly as well. And now you've got a really nice customized degree that would be just perfect to get you into something like a robotics field.
Perfect, thank you so much. Next question that came in, where can I learn to program? Or maybe do you have any suggestions on programs that can introduce students into that world?
Yeah, there are a couple of online services called Udacity, UDACITY, and then Coursera, I believe, COURSERA. And both of them have a number of free introductory courses for you to take to learn how to program. And I would start with that. I would start there.
Yeah, those are great. One, you'll need to be a little self-motivated. That's the only thing, which sometimes can be a little bit tough with high school students. Not that you're unmotivated, just you have 1,000 things going on. You have band and you have football. Sorry.
That's tough for everybody. That's tough for college students. That's tough for professionals. That's tough for everybody. That's why we go to school.
Exactly. Let somebody set up the schedule. Let somebody set up the homeworks and things like that. It's actually a pretty friendly way to do it. And most schools have summer programs for high school students. Like we have a program called SEEK that allows students while they're in high school. Matter of fact, it starts next week. You could do Java. You could do Python classes for credit. And Illinois Institute is really big in high school things too. So I'm betting Dr. Spenco's program has some summer classes in that. We also, through our first robotics program, have summer courses, not for credit courses in Python and in programming robots and things as well. And so look at some of your local colleges. Community colleges too are really big in these kind of little summer programs, and you may find a nice summer class focused on something that might be interested to you.
That's a great point. Those FIRST robotics or VEX robotics or all those sort of high school level competitions are great opportunities to help you learn how to code and give you motivation to do it. Not just, yeah, sure, Mom, I'm going to go up into my room and take this course for the next 6 weeks, and you're going to lose interest in the next, after a couple of weeks, and once it gets hard, kind of thing. So those are great opportunities.
Yeah, and I'm going to skip ahead to this next question because it's kind of on that same path. I'm interested in the STEM field, but I don't know exactly what I want to pursue in this stage in my life. What can I start doing now to broaden my horizon and find my passion? And I know you mentioned pre-college programs, which I personally think is one of the best ways to kind of solidify that. If you'd like to add on to that.
Sure. One of the key things about STEM is science, math, engineering, technology, and you can't make a word out of it. Maybe it should have been METS, because math is really the key foundation of everything in the STEM field. So one of the things I found in my years and years in advising undergraduate students is the ones who wanted to go into STEM but ended up having trouble in STEM were ultimately the ones who didn't have a very solid math background from high school. They may have done through geometry, algebra 2, things like that, maybe pre-calc, but they didn't have the opportunity to do calculus for one reason or another. Some schools don't offer it. Some schools, it interfered with a course or whatever. You never know what's going on, that they couldn't take that course. But really focus on getting your math courses in really good shape. If you can take AP Calc, do it. If you can't, do it through community college in the summer classes. They run a little faster, so you got to be careful about that. But it'll allow you to get a calculus class under your belt. But I find that people who do the best in the STEM fields are the ones who really have their math really under control, under their belt. And also don't be afraid to take a class over again in college. One of the things people think, I took AP Calc in high school, I got to take the credits and I got to move on. You're only 17 or 18. You got another 50 years, there's no rush. If you took AP Calc and you felt, yeah, I got a B in it, but I don't feel I really knew it that well, just take the calculus classes over again. It never hurts to have a great foundation, just like building a house. Houses on weak foundations fall down, right? So think about that.
I would just add to that, if you're looking to find your passion in STEM, I would expand that and ask you to just find your passion, of which STEM might be it, but it might not. And the worst thing you get is students coming in and they stick around to their sophomore year and they just don't like STEM. They don't like engineering, and it's hard. College degree in engineering is much harder than many other college degrees. And if you don't like it, if you don't really enjoy that, then don't do it. Find out what your other passion might be, instead of trying to pigeonhole yourself or try to sort of boost up some sort of passion that isn't there for STEM.
Yeah, that's a great point. Another thing too is, we're talking about electrical engineering. Should I be a mechanical engineer? Should I be this engineer? You don't have to major right away. You can be undeclared, and it's not a bad thing. Though a lot of people go, "Oh, you're undecided." That's, sometimes they call it undeclared, sometimes they call it undecided. It's not a bad thing to be undecided. So think about that too, to feed on Dr. Spenco's comments, that'll allow you to not pigeonhole so quickly. If right out of the gate you jump in electrical and take a few circuits classes and you realize, oh God, I really don't like this. Now you've got to, those credits are basically wasted to switch majors. So try to take things that are more useful across the board in the different engineering fields. There's a lot of common courses, and be undeclared for a while and be proud of being undeclared. Say it's a big world and there's a lot of cool things out there, and I'm still deciding where I want to be. It's not a bad thing. It's actually a good thing to be undeclared or undecided.
Yeah, those are really good points. And this next question, Dr. Farmer, you kind of addressed. My school doesn't offer computer science as a course. Would that lower my chances of getting admitted to computer engineering major? And as an international student, even if I take IB math and physics higher level?
Oh no, absolutely not. We probably a third or even more, maybe 40% of our students have had no high school programming, decided they want to go into computer science even. So a number of schools have kind of stepping stone programming classes now, like an intro class before the programming one class to help you sort of more gently get into programming. So it's not like you can even be behind. To be one additional course you'll take. Most schools it's in Python. It's called like beginning program or introductory programming in Python, and then you'll step into the more traditional hardcore languages like C++ or Java, depending on what your school's path is. But it won't hurt you at all. The only thing it doesn't help you kind of understand programming in terms of really deciding if you'll like it or not until you get to college. But it's a first semester class. You can take this stepping stone course in programming. You won't be behind. You won't be behind at all. I wouldn't stress about that.
Yeah, absolutely. And just from an admission standpoint, a lot of colleges do look at applications holistically. So we do consider what high school you're coming from, what courses you were offered. I know, speaking, on behalf of Kettering, we do look and see the rigor, did you try to take as many math courses as you could, different things like that. So don't stress too much about if it's not offered, that's out of your control. Next question, what are some good machine learning projects to do in high school? Any insight on that? Okay.
That's interesting. Sorry, Matt. Dr. Spenco, you want to go first?
I don't have anything. I mean, I got gazillion little projects around my house that I need done, and of little gizmos I want built in that. And maybe I would recommend, find some interest in that. Buy a little Arduino board. I wouldn't dive into AI right away. I'd get a little, spend $40 and get some Arduino powered kit off of a robotics website and tinker around in your basement for a little bit and just sort of start there. I don't know. That's how I'd approach it. I don't know.
Yeah, for sure. It's there really aren't any good, high school specific machine learning projects, but there's little things you could do. There's a lot. If you are good at programming and you happen to be decent at Python has a lot of libraries for machine learning, and there's some really relatively simple algorithms you might want to just play with first. There's one called like the nearest neighbor algorithm or k-nearest neighbor algorithm. You could literally write that in maybe 15 lines of code or use a library that has that. And you could do little things like play with, trying to think up features to recognize maybe your brother from your sister or something fun like that, or just little toy projects like that. There's a few algorithms like that are relatively beginner friendly, but from a robotics perspective, it would be harder. So as Dr. Spenco mentioned, Arduino kit or the Lego robotics set is pretty cool too. You can do some pretty interesting things with that if you're into the robotics side of things, as opposed to the straight AI sorts of things.
Perfect. Thank you very much. Next question, if I want to get into the autonomous and AI automotive industry, plus the actual designing and building of sport and race cars, what are the best areas of study for this?
You're in a couple of things. So designing race cars is really a vehicle dynamics thing, and which I love, by the way. I actually go to the Michigan Speedway and race NASCAR cars for fun and stuff. I love going fast. So it's a great field, but it's more of a vehicle dynamics kind of thing, which is hardcore mechanical. That's really in the wheelhouse of mechanical engineering. Autonomous vehicles can be, you can go a few different directions. If you go into the vehicle control side of life, you can deal more in the vehicle dynamics kind of thing from a mechanical perspective. If you want to go more into the sensing kind of side of life, which where my background is from, and it sounds like Dr. Spenco is also similar to that background. Then you're dealing with a different kind of field, and that's more the electrical engineering, computer engineering, those sorts of things in terms of the sensing side. So if you're really into the race car side of things and want to design race cars, and then tie it in autonomous, there's probably not going to be many autonomous race cars because that sort of takes the fun out of it. They want to have the driver drive so you can, be a fan of Michael Schumacher or whatever. But things that need to go fast certainly can be autonomous. And so I would recommend probably get into the mechanical side and get it and try to take their vehicle dynamics courses and elective. It's a really cool course, very difficult, but really, really cool.
Perfect, thank you. Next question, kind of going back to internships, do you recommend cold emailing, or do some companies, they have a way that you can apply for internships officially?
Most of them, not most, many companies on their job site will have jobs specifically for interns. Some companies don't necessarily have a rigorous internship program. So for them, you might want to look for something just as looking for entry-level people, and then write a good cover letter. Say, hey, I'm a high school student, or I'm a first semester college student, if you go to a school that doesn't have a co-op program, and you can write a decent cover letter that explains your interests. And again, as Dr. Spenco mentioned, if you're really good at having little summer projects, little gadgets and things you can write about in your cover letter, maybe even kind of be a little bold and have links to websites where your stuff is running, or pictures on your CV, your resume, of things you've built. If you go to other schools, like for example, Kettering is a co-op school. So we have an entire department of people whose job it is to connect with companies. We have 500 companies we've had internships with over the past 50 years, I guess, since we're Kettering and not GMI. And their job is to find you internships, find you co-ops, and you just basically have to tell them what your interests are, and they will dig around and find opportunities for you.
I would just like to add, it's an involved process. It's not really something that we can tell you how to do in 2 minutes. You got resumes, you got portfolios. You need to know how to write a resume. You need to know how to what to put on that resume. You need to know how to write a cover letter. There are departments in college that are set up for this. There are services that are set up to help you do this. Your advisors in college will help you do this. I would just encourage you. You guys are all still in high school. I think it's great that you're excited and you want to do these things and get on these internships, but it's okay. You have time. You can also work as a lifeguard too and still be good and get into college. And I mean, it's all good. So I would just encourage you to take your time, and you'll get to this stuff. These are skills you'll learn in college.
Yeah, just one thing to add, one thing that you might consider is maybe job shadowing. It's not a huge time commitment, and it might be a little tricky now with COVID, but most people are pretty excited to show off what they do to other people, and you can probably reach out about that. And that's just dedicating a day or two just to see a day in the life. So that might be a good option as well. Next question. I'm not very familiar with this. Maybe you will, one of you will be, but can you shed any light on cognitive science majors, on the cognitive science major?
Interesting. Actually, my research is applying human cognitive models to AI. So I have friends who were in cognitive psychology, and there's also schools that have actually cognitive science degrees now. They're very specialized. So they're kind of a marriage, if you will, of cognitive psych and AI and computer science kind of blended together. But they're not super common. If that's really your thing, you'll need to really dig around and look for schools that have that. But it's a great field. It's an interesting field, but very, very specialized. Probably, again, it's one of those things that's more often to have a master's or a PhD in that than a bachelor's degree in that. So things like psych would be a good launch into that. Computer science would obviously be a good launch into that field if a school doesn't happen to have a bachelor's in cognitive sciences. But that's, man, you guys are asking some really advanced questions. Sure, we didn't log into the wrong group, and this is like a post-college group, not a post-high school group, right? I'm really impressed.
Very, very ambitious. For sure. Another question, I know Dr. Spenco, it looks like you kind of jumped in. Which programming language is best for high school students? And is there a preference to maybe Java over Python or anything like that?
I just answered that. I just typed an answer there. I'd say Python's the hottest. I don't know anybody uses Java. C++ is necessary, but you'll get there, and MATLAB is used as well.
Perfect. And I think this next question, we kind of touched on this already. So is there a specific major called Robotics AI? If not, then how do you get into that? I think we kind of went over that a little bit, but if anybody wants to add anything.
Usually it's through, like, for example, AI in most schools, matter of fact, we're studying one right now, trying to put one through a concentration in AI. So you'll find schools that have like computer science degrees with concentrations, which are basically collections of electives you can pick. And so we'll have we're trying to push through an AI concentration. It won't happen in the fall, but maybe the fall after that. You're seeing just now master's degrees in artificial intelligence coming out. There's not a lot of them. A few schools have them. And maybe over the next decade, you'll see bachelor's in AI, I'm betting, come out. But again, there's only a couple of schools in the country that have bachelor's in AI degrees. So they're still a little bit new, or actually it's very new, because the field is so new. But look at concentrations. I know our computer engineering has a concentration that you could do. We're starting at Kettering a new bachelor's in engineering, or general engineering, that we're putting together a concentration in AI for that. But that's really where you'll see them at the undergraduate levels, in concentrations that allow you to tailor your undergraduate degree in a particular direction.
Great, thank you very much. Next question. Are there any projects or research, including your own, that you've kind of been keeping an eye on in the past couple months?
It's hard to say. There's so many things going on right now. It's almost like it'd be easier to name something that AI will never have a role in. Like, and I can't even think of that. Maybe even things like, look at my desk table here I'm working at. There's even going to be AI in manufacturing for quality control for wood lathes. Everything you can think of is going to have AI in it. And so what you're seeing a lot of research now, particularly in the engineering school levels, is applications of AI to a lot of specific things. Again, my field is pretty unique in terms of human cognitive models and AI. And that's fun because a lot of the AI models came out of mathematics side of life. So we call it artificial intelligence, but it was really almost artificial mathematics because it came out of math. And so there's a group of us that are really interested in kind of going back to basics and looking at the human side of things and how do humans solve problems, and trying to map those into artificial intelligence systems and things. But boy, anything you're interested in, as Dr. Spenco mentioned in the beginning, you can find AI research and applications.
I'm sort of interested right now, and we just submitted a proposal to look at the future of work and what it means, what automation means for the future of work. and sort of how humans work, why we work, how certain systems of work can lead to inequality, and how robotics may exacerbate that problem, and also how we can use robotics intelligently to not only to not exacerbate the problem, but to help perhaps uh, eliminate, or at least decrease the problem of inequality, and what it means to work. So I've got some interest in that recently.
Great, thank you. This next question, when I think of mechanical engineering, I envision the combustion engine. What can you do with a mechanical engineering degree for these new electric cars?
Are you kidding me? What can't you do? Yeah, there's the combustion engine, sure, but that's just a small part of mechanical engineering. So mechanical engineering is really broad, and if you told me I haven't looked at a Otto cycle or whatever thermal cycles for 20 some years. We do vehicle dynamics. Dr. Farmer brought that up. Control systems, so everything how you control what's going on. Going back to the combustion engine, how you take the carburetor out and put the fuel injector in. Well, the fuel injector has a control system. You have to program that. Everything that has to do with these electric cars also has these control feedback loops in them. You've got to thermally regulate the batteries. So you've got to heat them up when they're cold. You got to keep them cool when they're hot. They have motors themselves. Those are mechanical and electrical engineers who are designing those motors themselves, and getting the right torque and power profiles out of them. There's so much. Mechanical engineering is broad, and it's not going away. It's staying modern.
Thank you. It looks like we have about 3 minutes to wrap up. For those of you that we don't get to your questions tonight, we will follow up with you. We have representatives from the institution here. We'll get that contact information to you. But just to wrap up, if you each could just provide some advice, general advice to a student looking to pursue STEM, what would you say?
Don't be shy. Ask lots of questions. I know students, particularly as you're coming into schools, college is kind of a scary thing, and students are sometimes afraid of asking questions. And STEM often attracts us more introverted people as well, myself included, and we tend to not like to ask questions, but ask a lot of questions. Not only in class if you can, but go to office hours, go to tutoring sessions, go to recitation sessions, all the different places you can go that are more smaller and more intimate, if you will, for allowing questions to the faculty members. Ask questions of your peers. Go to advising center. Advising when I was a student was really just what courses do you want to take. Now it's such a holistic, all-inclusive thing. Everything from nutritional consulting to psychological services to tutoring to finding housing. It's everything. So make a friend at what they often call them success centers now is what the advising centers are called. Go to the success center often, make friends, so that when you walk in there, they go, "Hey Sam, welcome. I haven't seen you in a while." Get yourself known. Come to the departments. Don't a lot of my faculty complain, "No, I have office hours and nobody ever comes," and they're kind of forlorn. They're like, "Golly, well, how come nobody stops by?" And we love when you guys come to stop by. That's why we do this, right? That's why we're always thinking up new research areas. That's why we like to teach, is because we love sharing stuff with students. And so, reach out, just knock on a door here and there, and you'll be amazed at how many other doors that could open for you.
And in my 1 minute here, I would just say the best students that I see coming through, or some of the best, not all, but some of the best that come through are the ones that are taking these courses because they want to learn about stuff that they're already doing. So they're building something. They built whatever it is. I got students working on all sorts of side projects. They got lots of side projects. They're just interested in side projects. And then maybe that's coding something for you. maybe that's building a little gizmo, maybe that's rebuilding an engine or something, whatever it is. That's sort of the passion in STEM. And if you don't have it, it's okay. There are tons of other jobs and out there to do. It doesn't have to be STEM. So it's important to just find what you enjoy doing more so than being pushed into a particular field.
Well, that ends our program this evening. Thank you so much, everyone, for joining us. As you close out, there'll be a quick 4-question survey. So we hope that you'll provide us with some feedback. Sign up for more sessions. Both of these institutions will be presenting at 6 p.m. Central Time. There's sessions right after this one, and then again at 7 Central as well. You can sign up at strivescan.com. /CACHET. This will also be available for playback within 1 week. Have a good one, everyone, and we'll see you soon. Bye-bye.